Hi, everyone, and welcome to EDA Summit. Thanks for attending my talk. My name is Tamimi, and I'm a developer advocate at Solace. And today's topic is particularly interesting to me, and I would like to share some of the things that we've been working on at Solace, which is pretty exciting. Today's talk is about distributed tracing in event-driven architecture. And if you've attended previous talks about distributed tracing in general, you would have like a better idea on what distributed tracing is all about. I'm going to delve more into giving a quick overview on distributed tracing, observability, and then delve into a lot of details about event-driven architecture. And as always, I'm over here on the stream. If you have any questions, feel free to ask. So before we delve into the meat of the topic for today, I want us to take a step back and talk about particular topics. What is observability? Where does distributed tracing fit in the overall diagram, and what is OpenTelemetry? And this would set the path to what we will be talking about later about event-driven architecture and distributed tracing in EDA. So observability overall, in general, involves with gaining insights into the internal workings of a complex system. And that also includes analyzing and monitoring various components and interactions. From an observability standpoint, there are three different pillars for observability. There are logs, metrics, and tracing. And if we delve into each of the different sections, in a high level, logs are pretty much time-stamped records, which could either be structured or unstructured. Metrics are numeric measurements, such as percent CPU usage in your system, or aggregated measurements over time, such as the count of the number of events. And tracing focuses on the big picture of what happened to an event made by an application, user, or API. And this is where the tracing component, we kind of start focusing on distributed tracing. Because when we have a distributed system, this is where distributed tracing comes in place. It shows the journey of an event takes through multiple hops in the distributed system. So think of distributed tracing as a way to tell a story about a journey of an event that goes through different portions of the system. From a distributed tracing perspective, if we want to talk about why do organizations adopt distributed tracing, what are the benefits of distributed tracing, what are the things that should be taken into account before we take distributed tracing, before we implement distributed tracing, because the implementation of distributed tracing or having a tracing strategy in your architecture could sometimes be quite expensive. So you have to figure out what is the return on investment that you have before implementing distributed tracing. And some of the main benefits of distributed tracing that I'd like to cover here starts with debugging. First of all, it shortens the development time with faster root cause analysis. So if you have a complex microservice environment, and some problems happen or some issues you want to figure out what the root cause analysis is for a problem that happens. So the first advantage is debugging. Second is troubleshooting. So when you have a distributed tracing strategy in a complex distributed system, you can have an end-to-end observability to pinpoint a problem. Monitoring and optimization, again, end-to-end application performance monitoring to detect and resolve bottlenecks. Now, this is very important as well, because sometimes you want to figure out what are the issues that are happening in your system that could reduce performance. So if you want to enhance the performance in your system, you can see an end-to-end visibility of your system and say that, okay, here's the shortest path, or here's the path that took the longest time to execute. So improving the optimization of your system. And lastly, data lineage. So with distributed tracing, and another advantage of distributed tracing is cost reduction when you analyze a complex system. You can validate the trusted data sources, proof of delivery, this is pretty critical, and demonstrate some regulatory compliance. That also could be an advantage of distributed tracing. So now that we kind of took a quick overview on what observability overall is, how distributed tracing fits within the observability pillars, and what are the distributed tracing benefits, we can slowly start delving into enabling distributed tracing in event-driven architecture and figure out where does distributed tracing fit in an EDA system. And a quick note here that throughout the presentation, I'll be referring to distributed tracing as DT and event-driven architecture as EDA. So I'll be using the DT and distributed tracing interchangeably, and EDA and event-driven architecture systems interchangeably. Now, when we look more into so where does the distributed tracing fit in EDA, there is another point, there's another kind of like concept that I would like to highlight that would explain the big picture, and that is OpenTelemetry. So for those of you who know what OpenTelemetry is, you can check out the OpenTelemetry site on OpenTelemetry.io docs. It's pretty much an observability framework to collect and export telemetry data. It is an industry standard and vendor agnostic, and also known as OTel. So I will be using OpenTelemetry and OTel interchangeably. Now, the reason why I'm showing you this diagram in particular, or overall kind of like highlighting on what OpenTelemetry is, the industry overall has different vendors that are involved with tracing and observability solutions. So OpenTelemetry, becoming an industry standard and a vendor agnostic framework, helps the interoperability between different observability backends. So let me give you a quick overview on the OpenTelemetry pipeline. Think of it as there are services that are involved in here that you have your distributed system that releases kind of spans and sends information on what's happening. The OpenTelemetry framework is composed of three different components. You've got the receivers, you've got the processors, and the exporters. I'm not going to delve into a lot of details in here, but the reason why I'm showing this is to get a better idea on, regardless what end observability backend you're using, if your services are using the OpenTelemetry framework for a standardized way to communicate and a standardized way to release data, then that would really help with an industry standard for figuring out how to release your data or generate the spans that you need in your system. Okay, so now that I've talked about distributed tracing, OpenTelemetry, and what are the different components that we're going to be involved with, let me introduce a use case, a very simplistic use case on for distributed tracing and how that would fit with an event-driven architecture system. Let's assume that you have an application and there are servers and some databases that are involved in this application. The application does REST requests to the service where you have like a get or post request for the servers. And there's a database where the application also interacts with. Now, if we want to have a observability or if we want to implement observability and have a distributed tracing strategy or solution for this application that we would have an OpenTelemetry collector. And the application will be releasing or generating spans to the OpenTelemetry collector. And that kind of shows the interaction for every external service. So here I'm showing spans A, B, C. And the application, every time the application would do a request, for example, to the server, like a get request would generate a span. A post request would generate a span. An insert to a database will also generate another span. And these are kind of different spans or different actions that are happening within the application that are sent to the OpenTelemetry collector. And the OpenTelemetry collector sends these spans to an observability backend that gets stitched into one trace. So that on the backend, when we look at one trace, we can see that this application did a GET request, did a POST request, and did a database insert, and we can know how long each action takes. Okay, so far, so good. Let's expand this use case and introduce event brokers into the mix. Say that you have a message broker, and this message broker is also connected in an event mesh where you have multiple event brokers, and they're all connected together in an event mesh. Your application publishes a message to one message broker on a particular topic. You have other microservices and other applications or IoT devices that are connected to different brokers in the event mesh. Say that this is, for example, different geographical regions or different like different regions or different brokers that are connected in different locations, and they're all connected in a mesh. And your applications are subscribing to the same message. And let's say in one of the regions, you have another application that subscribes to the same topic that your application one published to. And this application will also do a database insert. And again, if we want to have a distributed tracing strategy in our system, we would have an OpenTelemetry collector that our application generates span to. Let's say we call this the span as span D. And this span D kind of shows an insert to a database. So application 2 subscribes to the topic, generates a span after inserting some data into a database. So now here we've seen kind of like we have an overall like kind of like big picture of a use case where there are applications and different message brokers involved in an event mesh where you can like publish and subscribe to events. But you can see here there's one particular problem is application 1 has spans ABC, application 2 has span D, and they both publish messages to or generate spans to an OpenTelemetry collector. But the overall picture of let's say the journey of a message, and again, going back to using the same terminology that I used earlier to explain what distributed tracing is all about, it shows the journey of an event that it takes from one hop to the other. There is an issue here, a critical issue, is that the event mesh or anything that's happening within the broker is seen as a broker. So I think of it as 2 different problems here we have. The overall system is not observable, and because there is a black box component in your system. So for example, we will not know. So let's say that we are looking at the traces that are generated from application 2 with span D. We will not know what happened to the event from the initial app 1 to app 2. A common use case, for example, is say that you have an e-commerce system or in a retail environment where the app 1 is kind of your front end, and you have somebody coming in to put some information in a cart. And then there's some interactions with servers, interactions with database to check the inventory. But there's also some other microservices or other information that are happening behind the scenes. Let's say that you have a fraud detection application or an ad analytics, and the event just propagates through different services. You want to have a common trend between all the events that are happening in your system so that you can observe it. But now this is the problem, is because there is the message broker in the mix and there's no observability. And now here I would like to introduce how tracing fits on and off in an event mesh within the context of the Solace broker. So let's say that you have a microservice that is publishing a message to an event broker. So very similar to the example that the use case that I showed earlier. And we're just gonna have I'm gonna zoom into this. So what we're gonna have is, as you see here, I'm gonna try to see if I can put a pointer in here so I can explain what we can see in this use case. So right now, what we have is a micro service that publishes a message to a Solace broker. The way that we do this is the guaranteed message gets enqueued into a queue, but we have a dedicated queue that is available in the Solace broker to put distributed tracing information. The OpenTelemetry collector, as I mentioned earlier, is an industry standard and it's open source. So Solace have contributed to this OpenTelemetry collector, and we have our own Solace receiver. So what the Solace receiver does is it connects to the Solace broker, and it binds to the queue that has all the distributed tracing information. And every time a message gets published, now here you can see that the context is being propagated throughout the system. So we have a microservice that publishes OpenTelemetry trace messages to an OpenTelemetry collector. The other microservice, which is, let's say, the subscribers generates messages to the OpenTelemetry collector. And now the black box component is not a black box anymore. And we can like pry open into the black box, and you can see that the broker component is also generating spans to the OpenTelemetry collector. And now when the spans are being sent to the OpenTelemetry collector, we can have end-to-end observability from a publisher to a subscriber through a message broker. So you can see here from the points that I have on the right-hand screen, the broker sends trace messages to a queue, and it passes to the OTel collector because we have a Solace receiver in there. And now when we want to add any other kind of like observability backend that connects to the collector, the stitching of the spans gets intelligently connected within the observability tool. So let's say that you're using Dynatrace or Jaeger or Datadog. You can connect the, you can have an exporter in your OpenTelemetry collector that exports all this information to the observability tool of choice. All right, so if we want to get back to our previous example use case that I showed over here. So now, earlier what I said in an example, we had an application that, that does particular activities and generates spans. We have another application that subscribes to a message that was originally published by application one, also generates spam. And what we want to do here is we want to have the ability to connect or have a correlation between span ABC and span D, so we can have a big picture of the system. This is where distributed tracing event-driven architecture comes in with the distributed tracing support within the Solace PubSub Plus program. So now we could have an OpenTelemetry collector, and the mesh or the different brokers that we have within the mesh could generate spans on OpenTelemetry collector. And now these spans would have the context of the message that gets propagated from application one to application two, and we would have a picture overall to see what happens to the message. So the full story, basically, this is kind of like another way to represent it. We would have publishers and consumers. There is an event mesh in the mix, and we have the Solace broker. And with the benefits of, thanks to kind of the OpenTelemetry framework being an industry standard and open source, we can connect all the information together and then see it in an observability backend of choice. So I did mention earlier some of the benefits of distributed tracing. So with having the Solace PubSub Plus broker support for distributed tracing, we can bring all the different benefits of distributed tracing and much more. So let's delve more into kind of like what are the information that we can get. Again, similar to what I mentioned earlier, we can have a faster root cause analysis and troubleshooting, because now we can track the progress of events on a hop-by-hop basis. Cross-protocol observability. So REST is very OpenTelemetry friendly, and MQTT and AMQP aren't. Another advantage of using the Solace PubSub Plus broker is we support protocol interoperability. Due to the multi-protocol nature of the Solace PubSub Plus broker, now you can have applications that can publish and subscribe messages using MQTT protocol. So if I would go back to my use case earlier, so you can see here, let's say that this is an MQTT IoT application that publishes and subscribes messages. Now we can expand this the distributed tracing functionality to MQTT and AMQP clients as well. Another benefits to having distributed tracing in EDA is we add observability to all applications, even if they don't support tracing. So now if you use an application that doesn't support tracing and it publishes messages to a Solace broker, a distributed tracing enabled Solace broker, at least now we can know we have a better visibility on where the message went and what are the information that are associated with this. And lastly, we enable non-repudiation by exposing a proof of delivery to all parties. So this is also pretty critical when it comes to distributed tracing in an event. So lastly, I want to step back here and let you kind of give you the opportunity to think of the potential use cases for this and have a bigger picture on where distributed tracing could fit in an event mesh. So we use this diagram quite often on kind of explaining event mesh in general and how the Solace broker could connect with different endpoints and entities. So you have here on the left-hand side, you have different applications and different cloud services. On the right-hand side, you have different iPasses, you've got connected places, you have IoT devices, you have all these different kind of applications in your system, and they're all connected together in an event mesh using the Solace PubSub+ broker. Now, imagine if you have a distributed tracing strategy as well within your system, and you can build a big picture, an end-to-end picture for a journey of an event that goes from different applications to different IoT devices through the mesh. These brokers could be located in different geographical locations around the world or different departments as well within your system. And now you can have a better picture on how the events kind of flow within your system. And lastly, I want to kind of leave you all with what are kind of the next steps you can do to get more information about distributed tracing. I know this talk kind of just scratched the surface on what are the possibilities and what is possible with distributed tracing in event-driven architecture. Definitely, we have continuous conversations and talks about these kind of topics on the Solace community. So join the Solace community at solace.community and feel free to ask any questions you have or answer questions if you know some of the answers to these. We have a video series about distributed tracing where I talk about distributed tracing in event-driven architecture. So if you go to YouTube and search for distributed tracing in event-driven architecture, you'll see a video playlist about distributed tracing in EDA. And then we are continuously releasing some more support for our native APIs for context propagation. So we will be adding or saying more information about this. So that's what I have for today. Thanks for coming to my talk. And again, if you have any questions, feel free to ask in the chat below. Otherwise, I will also be available on the Solace community or answer any questions you have on the videos. So thanks again for coming to this talk and have a great day. Enjoy the rest of EDA Summit.